Hi, this is Ms. Park, and in this video we were going to go through a complete trigonometric functions word problem. And in this problem called Dan at the wave pool, we're going to be asked to create a graph, write an equation, and then we will use the graph and use the equation to answer questions. And then we will tackle a question where we have to solve the equation. So let's have a look at our problem. So it's called Dan at the wave pool. If you're not familiar with wave pool, it's just a pool of water where people swim, but the machine comes on and it makes the waves go up and down. So if you're sitting in the water, you're actually going to go up to some highest point and then down to some lowest point until they turn the machine off, and then the water is just at its regular height. So when the wave is at its highest, Dan rises to 1.8 meters above the floor of the pool. When the wave is at its lowest, Dan is lowered to 1.2 meters above the floor of the pool. So what's happening is you have the floor of the pool, the maximum height is 1.8 meters and the minimum height is 1.2 meters. Then it says the timer starts when the water is at its lowest position. So that means when time is 0, we will be at our minimum height. Then it says it takes 10 seconds to cycle from the lowest position to the highest position and back to the lowest. Then it says sketch a sinusoidal function to represent the situation and show the important numbers. Then it says at what time is Dan 1.5 meters above the floor of the pool? And then it says to write an equation to represent the situation. And finally it says at what time is Dan 1.7 meters above the floor of the pool? So as we go through the solution, you will see that question B and question D are both asking for times for a given height, but the solutions for B and D are very, very different because of the significance of 1.5 and 1.7. So I'm going to go back to my paper here and let's write a few things. So first of all, we know that the maximum height is 1.8. The minimum height is 1.2. We know that the timer starts at the minimum, so I'm just going to write that down. And we know that it's 10 seconds to go from the lowest to the highest, back to the lowest. So that tells us that there's going to be a period of 10 seconds. So I'm going to sketch this. Okay, so here's my 0, and 0 is the floor of the pool. So the minimum height is 1.2. The maximum height is 1.8. So that tells me that my average is halfway between the two is 1.5. Okay, now my period is 10. So that's one complete cycle from the lowest to the highest to the lowest. So now I'm going to divide that into 4 equal parts. So this will be 5, 2.5, and 7.5. And because the timer starts at the minimum, I know my first point when t equals 0 is at the minimum. So I go minimum, average, maximum, average, minimum. And I have this. Okay, and so that looks like, if I, didn't draw it great, but that looks like a cosine graph. So I might as well write this as a reflected cosine graph. I could write it as a sine, starting from the average. I could also write it as a cosine starting from the max, but it's easier, I think, in this case, to write a reflected cosine. I'm just going to flip back to the question and see if they specified. Oh, they did. They said write it as a sine. Okay, so if they don't specify, you can use any sinusoidal function, but it says to write it as a sine, so I will, which means I'm going to need to start here at the average. This will be my phase shift. So y, y represents the height above the floor of the pool. And what do I need? I need an amplitude. I can see my amplitude is 0.3, the distance between the average and the max, or the average and the min. So 0.3 sine. And now I'm going to need a k value. Well, my period is 10. So the k is 360 divided by 10, which is 36. So now I have a 36. X is, so this is time and height, but they're calling x and y, but that's okay. So I'll just call this as y, this is x, same thing. They're just variables. And now my phase shift is 2.5 because I want to start with sine. and then I'm going to have to add my Q value, which is my average, and that's it. I've got an equation. So now we have completed questions A and C. Actually, I skipped B because it was so easy to write the equation, I just jumped to it. But really, we should look at question B. At what times is Dan 1.5 meters above the floor of the pool? So that was question A. Here's question C. Let's go to question B. So question B, all I have to do is look at the graph because 1.5 is a very significant number. It is our average. So I'm going to write here height is 1.5 meters after 2.5, what is that, seconds or minutes? Seconds, 2.5 seconds and 7.5 seconds. So that's within one cycle of the waves going up and down. The height is 1.5 meters at those two times. Now, if they said within 1 minute, let's say, when is the height 1.5 meters? Well, then we have to consider that there's 6 of these cycles of 10 seconds each. And so each of these values, the 2.5 seconds and the 7.5 seconds, will occur again 10 seconds later and 10 seconds later and 10 seconds later and 10 seconds later and so on. So we'll have to consider more cycles. But it doesn't say, so we'll assume that it's just within one cycle. So we figured out the height, we figured out the time to make the height 1.5. What if they said, what is the height at, after 4 seconds? Well, if they asked that, then we could use our equation and substitute in the time of x equals 4 into here and calculate the height. So that's how we use our graph and use our equation to solve problems. There's a type of problem that's a little bit more challenging, which is this question D. And the question D says, at what times is Dan 1.7 meters above the floor of the pool? So this one, 1.7 is not a significant number for us. It's somewhere over here. And we can see that there should be two answers, one here and one here, but we can't tell from the graph where they are. So question B is the one that's more challenging, where we have to solve the equation. So what I'm going to do with question B is I'm going to set up D, I'm going to set up the equation, and I'm going to make my height equals to 1.7, and then I'm going to solve for the time. Okay, so 0.3 sine 36 times x minus 2.5 plus 1.5 equals 1.7. And now I'm going to start isolating the x. I'm going to have to isolate the sine first. So I'm going to go 0.3 sine 36 times x minus 2.5 equals 0.2. And then sine of 36 times x minus 2.5 equals 0.2 divided by 0.3. And if I want, I can let theta equal 36 times x minus 2.5 just because it looks a little more friendly. So I have sine theta equals, I'll just change this fraction to 2/3 to make it simpler looking. And you can see this one is not a special angle because we don't know any special angle with sine of 2/3. So I'm going to have to use my calculator. When I use my calculator, I will use the inverse function, but it's not theta. It's the related angle that I'm going to get. So I'm an inverse, and then I'm going to go 2/3, using my calculator, 41.8 degrees. So I'm going to say that's approximately 42 degrees. Okay, sometimes the question will ask you to round to one decimal place. Sometimes it says whole number. Generally degrees, we do the whole number, and other units will do one decimal place, but it should specify in the question. Okay, so again, that's not theta, that is the related angle, and sine is going to be positive in quadrant 1 and quadrant 2. So I've got a 42 degrees in quadrant 1 and a 42 degrees in quadrant 2, which tells me that my theta equals 42 degrees, or my theta is equal to, so measuring in standard position, 180 degrees minus 42 degrees is 138 degrees. Now, question's not asking about theta, the question's asking about x, so I have to put my x back. So this is x minus 2.5 is 42, or 36 times x minus 2.5 equals 138. Now I got to solve this for x. So x minus 2.5 is 42 divided by 36. I'm just going to avoid using the calculator until the very last step. I'll do that here. And so x is equal to 42 divided by 36 plus 2.5, 3.666. So let me go 3.67. And then over here, x minus 2.5 is equal to 138 divided by 36. So x is equal to 138 divided by 36 plus 2.5. I'm just using the calculator at the end again. Let's approximate these. So 138 divided by 36 plus 2.5. 6.33333. Okay. So there's my two values of x. But my next thing is that I have to consider what my k is. My k is 36, right? There's my k. So when I'm getting these two answers, I'm actually, I'm only getting them in the first cycle. So we have to think about, this is all in the 10-minute cycle. So we have to think about what the question is asking. So let me go back to the question. In this case, it says, at what time is Dan 1 point? Okay, it doesn't say. So we can give our answer for just the one cycle. So that's the same as in question B. If it doesn't specify how many cycles to give the answer for or for what period of time, then we can assume it's just one cycle. Since my K was 36, and I know from the picture, my graph, that the period is 10. If it asked us for more times, we would have to add 10 to each of these times again and again and again until we get all the times that they want. So right now, I'm done the question. I can say, I can say, therefore, he is at 1.7 meters after, and then whatever kind of rounding you want, 3.7 seconds and 6.33 seconds. Okay, the question might say something like, when is he at least, if it said at least 1.7 meters, then you would say between 3.7 seconds and 6.33 seconds. So all that time in between, he would be at least 1.7 meters high. Okay, so we can see that here. There's our 3.67 and there's our 6.33, these 2 points right there. Okay, and that's everything. That's how you solve a trig word problem, including having to solve the equation. Okay, hope that was helpful. Please keep practicing, and thanks for watching.